going to start talking to you about empirical formula just because it deals with ratio, and ratio is pretty important, and also it uses that first equation, moles equals mass over RAM. So let's look at the formula for glucose, C6H12O6. What would be the ratio of carbon to hydrogen to oxygen? And those of you who are more astute could just look at that and do it instantly, but if you're less confident with this, the procedure you need to follow is to divide through by the smallest number in that formula. So the smallest number in that formula is 6. So we're going to divide all those numbers through by 6, and that will give us the ratio in its simplest form. So looking at the first one, carbon, 6 divided by 6 is 1. Hydrogen, 12 divided by 6 is 2. Oxygen, 6 divided by 6 is 1. So that when we do that, the simplest ratio we could get would be CH2O in terms of whole number ratio, and it's whole number ratio as close as possible that we're trying to get in empirical formula. Now let's look at a more likely question, and that's when we're not given the formula to take it down to the empirical formula, but we're given the masses. So in order to do that, we first need to turn these masses into moles. So let's look at the first question. We've got 6 grams of carbon reacting with 2 grams of hydrogen. What is the empirical formula? So the first thing we need to do is turn that into moles. So we're going to do that by doing mass divided by RAM. So 6 divided by 12 is going to give us the number of moles of carbon that we've got there. And 2 divided by 1, which equals 2, is going to give you the number of moles of hydrogen you've got there. So when you do that, we realise we've got 0.5 moles of carbon attached to 2 moles of hydrogen. Now, that's what we need to do next is divide through by the smallest number. Now, the smallest number out of 0.5 and 2 is obviously 0.5. So 0.5 divided by 0.5 equals 1. 2 divided by 0.5 is equal to 4. So the empirical formula of that compound, therefore, is CH4. Looking at question 2, suddenly they've switched from number of grams to percentage. What a percentage of these different elements? Well, we don't need to worry about that. We're just going to do this in exactly the same way as we did question 1. So we're going to take 52.1 and divide it by the RAM, which of carbon is 12. Okay, and we're going to do 13 divided by 1, which is going to be 13, and 34.9 is going to be divided by 16. So when we do all that, we realise we've got 4.3416 recurring moles of carbon, 13 moles of hydrogen, and 2.18125 moles of oxygen. Now, it's going to be a good idea to keep all of those values to the highest number of decimal places, but you're never going to record your final answer in loads of decimal places. Okay, so once we've got that, what is the procedure? Once again, we're going to divide through all of these by the smallest number. And the smallest number there is 2.18125. So we're going to divide everything through by 2.18125. And when we do that, we come out with a carbon value of 1.989, a hydrogen value of 5.96, and obviously the last one must be 1. So that is really close to C2H6O1, or just O. And that's it. That's the empirical formula. Let's look at another question. And this question says, how much hydrochloric acid will we need if we used 14 grams of magnesium oxide MgO? It means to fully react with it. Now, the problem with this question is there's 2 different ways of working it out. So I think most of the revision guides and most of the GCSE books go with the mass route, and that's often quicker. But so this is the one you perhaps really need to listen to. But if you're thinking of continuing on in chemistry, you will need the moles route as well. And the frustration with the mass reader is it doesn't really use moles equals mass over MR particularly. So let's have a look at how this works. So the first thing we're going to need to do is work out the relative molecular masses of MgO and 2HCl. Okay, so once we've done that, we can determine that the relative molecular mass of MgO is 40 and of 2HCl is 73. So what that's telling us is that 40 grams of MgO is going to react with 70 grams of HCl. But we don't have 40 grams of MgO. We only have 14. Okay, so how are we going to work this out? Well, the way to think of this is, well, first of all, how much would 1 gram of MgO generate? So to turn that into 1 gram, you'd do 40 divided by 40, it's a bit like the empirical formula here, and then times it by 14, okay, which would give you 14. But we want to do that process to the other side, which is the unknown, which is the HCl. So what we're going to do there is going to take 73 and you're going to divide it by 40. And then you're going to times that by 14. Okay. And when we do that, we get the answer, which is 25.55 grams. So in summary, just to repeat what we'd do, the steps would be to underline the substances whose mass you're given and whose mass you want to find out, and that allows us to ignore all the other RMMs. We don't need to worry about those. You'd need to work out the MRs, the RMMs, and ask yourself, well, how are we going to get 1 gram? Well, okay, so 1 gram would be divided through by 40. Okay. And next, you need to multiply it by the actual number of grams you've got, which would be 14. Now, in terms of the moles root, what we need to understand here is that equation MgO plus 2HCl going to MgCl2 plus H2O, you're already talking about moles. That's what that number in front means. When it says 2HCl, it means 2 moles of HCl are going to react with 1 mole of MgO to produce 1 mole plus 1 mole of the products. Okay, so you can actually work this out with moles equals mass over gram. And if you were going to do it this way, what you would need to do is look at how many moles you have got of MgO. Okay, and to do that, you just do 14 divided by the MR. Okay, and when you do that, you would work out that you have 14 divided by 40 is you have 0.35 moles. Now, to completely react that, you are going to need 2 times 0.35 moles. And we know that's because of the big 2 in front of the equation there. And that's kind of obvious in this one. If you had a more complicated one, this is going to sound a bit silly, but think about the process that you're actually doing. You're actually getting a ratio through here to its smallest number. So MgO would be 1 divided by 1 equals 1, and then you'd want to do the 2 divided by 1 equals 2. So that sounds really silly that I've done that, but actually, just like in the empirical formula, you need to divide through by the smallest number to come up with that 2 there. Okay, so I have been given 0.35 moles. How many moles are going to react with 0.35 moles? Well, using the equation, I know that 0.7 moles are going to react. Okay, but the answer calls for an answer in grams, so we need to turn the 0.7 moles into grams. Now that just involves us rearranging the equation moles equals mass divided by mR, 2 moles times mR. So 0.7 moles times the mR, that will give us the answer, which should still be 25.55. So it's 0.7 times 36.5. So notice I don't need to double it twice. Because I've doubled the number of moles, I don't need to double the MR there. So just to recap, underline the substance whose mass you're given and mass you want to find out. Calculate the number of moles you have, which will be the mass over the RAM, 0.35 in this case. Identify the number of moles you need by looking at the ratio. You need twice as much here, and you divide through by the smallest number here to come up with that figure. And then multiply the moles you need by the MR. That's a rearrangement of moles equals mass over RAM equation. And you still come out with the same answer, 25.55 grams. But to be honest, in that particular example, perhaps took slightly longer than the mass route, but you will need to know how to do calculations like that in the future.